Jagriti, and I, Dr. Neha Khurana, being the coordinator of this AICT ATAL sponsored 1 week faculty development program on advanced computing, invite first of all welcome all the participants to this program. Starting with the introduction of our university, I want to mention here that Maharishi Dena University Rohtak, established in 1976 as a residential university with the objective of promoting interdisciplinary higher education and research with special emphasis on studies of environmental, ecological, and life sciences, and is continuously making a rapid progress to emerge as a leading educational institute of nation. Now, it is a teaching cum affiliating university for a track record in academic research, literacy, and cultural activities and sports. Currently, there are 38 postgraduate departments and many faculties in the university. Territorial jurisdiction of the university extends to 10 districts of southern Haryana. The doctorate of distance education is providing quality education to students with the traditional UG/PG courses as well as information technology and management program. With all these efforts, Maharishi Dayana University received A plus NAC grade in March 2019. And when I talk about university's large campus, it provides excellent infrastructure, facilities, and necessary student supports. And hostel facilities are for about 4,000 boys and 3,000 girls is available on the campus. This was about our respected university, Maharishi Dayanand University, Rohtak in Haryana, India. And when I talk about the institute, which got this AICT ATAL FDP grant. This is named as University Institute of Engineering and Technology, which was established in year 2005 with the aim of providing technical education in engineering and technology. It offers 6 BTech programs of 4-year duration in mechanical, electrical, civil, computer science engineering, electronics communication, biotechnology, and one more added, that is artificial intelligence and machine learning, emerging areas. In short, we can say that UIT has become a preferred destination for BTech and MTech, and also it is a destination for PhD aspirants also. When I talk about University Institute of Engineering and Technology, I want to mention here that this institute has got TQ2 grant of World Bank project of from, and this technical education quality improvement program TQ aims to upscale and support the ongoing efforts of Government of India for improving the quality of technical education and enhancing the existing capacities of institutes become dynamic, demand driven, quality conscious. Now, again, I formally welcome all the participants to this AICT sponsored ATAL FDP program on advanced computing, one of the most emerging topic of the technical background, with technical background, and under the supervision of our worthy Vice Chancellor Professor Rajbir Singh and being motivated by Professor Ashwini Dhingra, Director UIT, we are here able to got this grant. This program has about 150 participants from overall Haryana and overall India. And we have many reputed speakers from overseas and across the India. This is all from my side. Again, welcome all of you. And now over to you, Jagriti.
Thank you so much, ma'am. So now it's my pleasure to introduce our first speaker, Professor Rajkishore Nayak sir from the School of Communication and Design, RMIT University, Vietnam. His research focuses on sustainability and circular fashion, technology applications, and advanced materials. He has successfully completed several funded research projects in Vietnam and in Melbourne and has an outstanding academic record with around 180 research publications. So we are truly honored to have Professor Nayak sir with us today. So now, sir, you can continue the session.
Thanks, Zagriti. Let me start with sharing my screen. Can you see my screen now?
It's visible, sir. Nayak sir, it's visible.
Yes, sir.
Okay, thank you. Let me present and then start. Um, I would like to thank Jagriti for following during all these activities. So she was, calling several times to join on time and do all these arrangements. Again, thanks,
Thank you,
Nehama,
sir.
for organizing such a great event. It's a great honor to talk all of you. My name is Rajkishore Nayak. I am working as a professor with the School of Communication and Design. It's already 17 years I joined in RMIT Melbourne. And out of these 17 years, half of the time I'm in Vietnam, half of the time I was in Melbourne. So today I'll be talking about AI and technology applications in fashion manufacturing. I'll take some case studies from Vietnam. Again, thanks AICT for this opportunity under this AICT auto-sponsored faculty development program spanning from 19th of June to 24th of June, 2026. In the beginning, I was thinking to talk general AI and applications in general supply chain. But again, I found that one of my colleagues will be delivering in the similar topic. So then, being from fashion background, I decided to continue on the AI application in fashion manufacturing, retailing, and all other areas of fashion. So today, I'll be taking you through the introduction, AI in fashion applications,
Sir,
such as
uh,
fashion
sorry for
design,
the interruption.
production.
Hello.
Sorry,
Sir, your screen is not maximized. I think so.
it's not.
Maximize.
Okay, can you see now? I already
Yes, sir.
shared in the.
Yes, sir. I can see. But your this Google Meet is also on the screen.
Google Meet in not in the screen.
Yeah, it is coming over the slides. I don't know
Oh, sorry.
whether it is for all the.
Nayak sir, kindly press F. Okay, okay, it's okay, fine, sir. Now it's
Yeah, now
visible.
it's okay. Now,
Sorry. I did not know that.
now, sir, click on slideshow.
Can
Yes, sir.
you
Now it's
see it
okay.
now?
Okay. Yes, sir. Yes, sir. Thank you.
Okay, let me hide this one also. Okay, I'll be discussing about applications of AI in designing, in production, retail management, customer relationship management, returns management, and many other areas. Then conclusion, I'll discuss about some of the research opportunities or PhD opportunities in Vietnam and funding opportunities also. We can plan for applying some funding grants. Then finally, the references. Coming to the fashion sector in Vietnam, Vietnam is doing great in recent times because of the significant rise in the tariff in India and China. So the orders in Vietnamese industries are increasing rapidly. Therefore, to meet this high demand of the foreign brands, so the industries are getting ready to implement different technologies, including AI, RFID, blockchain, so many other technologies. If you look at the fashion sector, basically we talk about clothing, accessories, and beauty products. Fashion sector is experiencing ongoing challenges in design process, production, promotion, and sales. The complexities of supply chain management, together with ever-changing impact of the technology, artificial intelligence, and sustainability trends determine the dynamics of the market. Recently, sustainability trends is getting more emphasized in fashion sector because of European Union and US. They are getting stricter in sustainability, like environmental pollution, corporate social responsibility, and um, ethical fashion. If you look at the fashion market, there is a lot of fluctuation in the demand, and consumers' expectations is very much difficult to predict. Sometimes there are natural calamities like we have seen in 2019. COVID-19 was an example, and I was here. I witnessed how the fashion industries struggle to survive when the demand drops. So we can say it is driven by market demand, and it's highly volatile. That means today there may be high demand, tomorrow there is no demand for the same product. Coming to the role of technology and AI in fashion, in spite of several developments in technology and artificial intelligence, fashion manufacturing still employs manual operations. If we look at many of the developing countries, including India, Vietnam, Bangladesh, so still many of the production processes, they are done by manually without the application of artificial intelligence or robotics or even the different types of technologies. The growing influence of technology such as 3D printing, virtual reality, augmented reality, and blockchain has a profound effect on the future of the sector that promote sustainability and ethical norms. Technology and AI play a role in driving digital innovation and transforming the fashion industry. Now I'll briefly discuss about AI applications in fashion. Last year, actually, we published a book that includes all different AI applications in fashion, but I will take you through these interactive chatbot applications in fashion. So I'll go through the history, technology, and different applications. The term chatbot was first mentioned in the year 1990s. During this time, several early chatbots were created, including Tiny Mod, Dr. Sabaso, and Alice. The paper authored by Adam Polu, and others provides a comprehensive account of the notable progress made in chatbot technology since about 2001. And in recent times, there are many authors, they are focused on working in this chatbot area. In the beginning, the applications involved creation of smarter child and emergence of personal voice assistants such as Siri that everybody knows, IBM Watson, Google Assistant, Microsoft Cortana, and Amazon Alexa. I think some of us, we already use or we are currently using them. Coming to the definition of chatbot. Chatbot is a computer program designed to simulate conversation with human users, especially over the internet, by processing and generating human language. Initially, the first chatbots operated by recognizing keywords from user inputs and then using predetermined rules to convert those phrases into corresponding responses. If the keywords are not detected, The system responded by providing a generic response that was used in a previous session. How chatbots are functioning? Chatbots are designed to mimic human conversations that are transforming the fashion business through efficient and personalized interactions. I have been to many industries here in Vietnam, including the large global enterprises like Gap, Nike, Adidas. I have seen how these technologies are reshaping their designing process, manufacturing process, and transforming the customer experience. I'll discuss, but again, there are some other sides also when you go to the real manufacturing units. Okay, coming back to the functioning of chatbots, by employing natural language processing, which is acronymed as NLP, and machine learning programs, they can provide prompt assistance, customize product recommendations to different types of consumers in a retail. We can track order. The AI applications can emphasize the influence of digital innovation on enhancing client experiences. In fashion industry, chatbots play various roles, such as providing personalized styling advice. So this one I have seen with Marks and Spencer. So you can go into a retail store. The 3D scanner is going to scan your body. Then from that scan, your body measurements and your like your color and body construction, it can recommend different types of garment that will be best fitting or best aesthetically best appealing to you. So they can recommend product based on the user preferences, answering customer queries, facilitating online purchases, and enhancing customer service experiences. They can also assist in guiding users through the shopping process, providing fashion tips, and offering real-time assistance with outfit selection. Chatbots in the fashion industry are empowered to instantly provide users with information. They perform functions in online stores, such as searching for the goods and displaying products, and are expected to take more functions due to advancements in the AI and machine learning. Chatbots play a crucial role in fashion retail as the first point of contact for consumers, providing efficient customer service and contributing to the overall brand experience. So in this slide, I have summarized all different AI applications in fashion, starting from the production and supply chain, then fashion retailing, customer service, and marketing. So I'll take you through the detailed discussion of each of these points. Coming to the first point, production and supply chain, I'll be covering product design and development, supply chain optimization, quality control and defect detection, demand forecasting and inventory management, sustainability and material innovation. Then in fashion retail, I'll be covering personalized shopping assistance, virtual try-on and personalization, order tracking and updates. In customer service, I'll be covering instant customer support, returns and refunds, size recommendation. Then in marketing, I'll be going through promotional campaigns and discounts, style advice and fashion tips, and social media integration. Coming to the very first application of AI in product development. So again, product development is quite complex process. Till now, many garment industries, they do by famous designers. They follow the trends from other parts of the world, like particularly from Europe. The global fashion is influenced by like fashion in Italy or many European um, countries. But with AI, we can predict what the demands will be for the coming season, and accordingly, we can do the product development. So AI can produce novel ideas by analyzing fashion trends, user preferences, and historical data. Whenever we go for um, fashion forecasting, we use past data in a significant way, and we take the current trend. So we amalgamate between the past and the present to come up with the recent trend. So with the application of AI, it can aid designers in generating novel styles, patterns, and silhouettes, resulting in improved creativity and efficiency in the design process. So we have an experienced designer who uses a lot of AI in the product development process. AI is utilized to create and enhance different design options, enabling quick development and improvement of different types of garments, styles, silhouettes, and different types of product. Coming to some of the brands, they use AI. I have taken this example from Nike. Nike has incorporated AI into their product design process by leveraging algorithms and computational design tools. AI is utilized to create and enhance different design options, enabling quick development and improvements in the entire fashion supply chain process. This AI integration allows Nike to investigate novel design concept and expand the limits of innovation in athletic clothing. So recently, I went to one of the Nike stores in Chicago, and then I found how advanced they are. So they employ AI to suggest you what type of shoes, what type of sportswear you can select from the store. So they have basically a scanner that will be scanning your body and then do all the measurements while you are running in a small confined space inside a small room. Running means it's like a automatic moving place. Then you run there. So in small distance you run, and then the cameras mounted in the wall and in the sides, they're going to scan the entire body, and they're going to find like your postures, your body movement, and your steps. So they like create amazing experience for the customers, and they can find out exactly what size of the suit, what size of the clothing you need. So that was a great experience in the US. When I went, I had experience. But coming to the developing countries, I think still we don't have that many applications in developing countries like in Vietnam or maybe in India. We don't find that sort of applications. AI applications in supply chain optimization. AI may assist to improve the garment supply chain by enhancing forecasting accuracy, demand planning, and inventory management. This is one of the most challenging tasks for many sportswear companies, many garment retailing companies, because, as I mentioned before, we cannot predict the customer demand. And many times, the brands, they buy in excess quantities, maybe like 10-15% in excess quantities, which cannot be sold. And finally, they burn these clothes, or they shred these clothes and throw into the landfill. So with the application of AI, we can save these inventories going into the landfill, or we can save the resources being wasted. Then the next one is machine learning algorithms utilize historical data, market patterns, and external factors to forecast demand, mitigate stockouts, and decrease surplus inventory, which is a major problem in the fashion sector. If you compare with electronics or automotive, there are not much wastage that we produce in fashion supply chain process. So this is another example of Zara. Zara is a famous fashion brand from the Inditex group located in Barcelona, Spain. So Zara is well known for its quick production and turnover of trendy items. They use AI algorithms to predict customer demand, analyze sales trends, and improve the management of available stocks. So we did one project with Zara, and I was surprised to hear from the CEO of Zara that the total time they take to concept from like concept to consumer. That means from thinking a product, then bringing to the consumer. So concept to consumer time is less than 1 month. If you compare with Nike, Gap, Adidas, it may be 44 weeks or more than 44 weeks. But for fast fashion brands like Zara, the turnaround time is just 1 month, which is possible because of the application of AI and robotics in the manufacturing, or um, application of different technologies in the manufacturing process. Zara utilizes AI to make precise forecasting about fashion trends and adapt its production and distribution process appropriately. This strategic approach minimizes the likelihood of having excess inventory or insufficient stock. So many times they cannot predict the demand correctly, so they run out of the stock. So if they are running out of the stock, the consumers have a bad experience. Maybe the consumers will not come back to Zara again. But by the application of AI, so they predict consumer demand very accurately. That helps the brands to keep their customers or maintain customer loyalty. Then AI helps to reduce excess stock and stock runouts by vendor managed inventory. So this is a new term, VMI. VMI indicates that the vendor will know what is the exact stock situation of the brand. If the stocks are falling down, then they will start producing the new product and they will be supplying before it runs out. But again, when there is excess of stock, they can see that these products are not selling, so they don't manufacture. And vendor managed inventory reduces the lead time. That means it is faster than the normal inventory management process. It takes less time and it is cheaper than the normal inventory management process. This is the supply chain optimization summary. So I have explained everything in the fashion supply chain process, starting from the manufacturing, how it goes to the warehousing, then distribution process, then the product is going to retail, from the retail to the customers. And again, from customers, we get feedback to select the right type of raw material. And then we communicate to the supplier. So we can say this process goes in a loop. So starting from you can start from anywhere. So normally we start from the raw material selection, and then it goes in a clockwise manner. But again, with the integration of AI, we can start from anywhere and then we can move around this circle. Before I go to AI applications in quality control and defect detection, so if you got any questions, you can ask me, or you can chat your questions in the Google chat. Then I'll see this and then I'll answer your questions. So if anybody got any questions, you can ask me now, or else you can ask me in the end. Okay, if there is no question, I'll continue, and then maybe we can have a Q&A session in the end. So coming to artificial intelligence in quality control and defect detection. So this, I have seen direct application in many fabric manufacturing units. They inspect the fabric quality by applying artificial intelligence. So basically, the fabric inspection is a manual process, but with the application of AI, we need to install different types of cameras on the top of the inspection machine, and these cameras will be uh, capturing the movement of the fabric, like the motion picture of the fabric. We have to run the fabric in a machine. Then the cameras mounted on the top of these machines will capture these videos of the fabric. And whenever there is a defect, they will compare with the images stored in the device, and they will either stop or they will put some note in the system saying that there is X, Y, Z defect in the fabric at this location. So then when the people involved in this quality assurance process, they check, they then directly go to that fabric and directly investigate what this defect is. So this process is quite accurate, and it is like it's a continuous process. When we do manually, operators get tired, and then sometimes they are like mentally too much tired to look the fabric defect, and sometimes also they cannot precisely determine some minor fabric defect. But with these AI applications, we can produce better result with more efficiency and better quality control of the fabric. Similarly, some of the industries, they inspect stitching defect such as loose threads, skip stitches, holes, stains, and seam puckering. That is a standard quality control method in garment industries. So these industries actually, they work with large fashion enterprises like Gap, Nike, Adidas. But when it comes to small and medium-sized enterprises, or the suppliers or buyers from Asian countries, this artificial intelligence or technology applications is very limited. Then the next application of AI in quality control is fabric color, then accessories inspection, and overall quality inspection, that are the frequently evaluated using manual operations, but many of them, they are applying AI to inspect all these parameters. AI-based computer vision or CV systems can automatically detect fault, irregularities, and inconsistencies in textiles, patterns, and stitching. AI can facilitate effective quality control procedures, minimize human um, fallibility, and guarantee uniform product quality. So when I was working at IIT Delhi campus, I was working with Professor Behera in the Department of Textile Technology. That time, we had a sponsored project to develop AI-assisted fabric inspection system. So I was one of the team members, and we had some software developers to develop this software to automatically detect fabric faults in different types of knitted fabric, woven fabric, non-woven fabric. So that project was a long project, and I think I worked about 2.5 years in that project, including some other project also. Okay, coming to the next page, we have some examples from the global brands, how they apply AI in quality control and defect detection. The first example is from Stitch Fix. That is an internet-based service for personalized fashion advice. They use AI algorithms to evaluate the caliber of clothing articles. Their utilization of computer vision technology enables them to examine apparel photographs and identify any flaws in stitching, color, pattern, or overall quality of the product. This measure guarantees that customers are provided with top-notch merchandise. So when we compare with the manual inspection system, these AI-assisted inspection system are more accurate and they produce result um, with better accuracy, and the like customer satisfaction again is the prime reason behind the implementation of AI. Then next one is demand forecasting and inventory management. AI algorithms can reliably forecast demand by analyzing enormous amount of data such as past sales data, market trends, social media sentiments, and weather patterns, because all these factors influence the consumer demand. This AI application greatly assist clothes businesses and merchants in optimizing their inventory levels, minimizing instances of stockouts, and reducing situations of overstocks. This is another example from Asos brand. There is an e-commerce fashion vendor. This brand uses AI algorithms for predicting demand and managing inventory in the supply chain process. They utilize machine learning methodologies to examine client data, browsing patterns, and purchase records to forecast trends and foresee the demand for various clothing goods. This enables them to optimize their inventory levels and assure timely availability of the appropriate products. So coming to these applications, sometimes I use the website Amazon to buy some product. So, sorry, there is a noise. So basically in Amazon website, when I search some product, it based on my past like search experience or whatever I purchased in the past, it will bring the product, bring this product to me. So in the top of the search list, I'll be seeing the product that I bought before, and then when I go down, there will be product that I never bought. So this is done by the application of AI. Then the next application is sustainability and material innovation. AI plays an important role in improving the sustainability in the garment business by optimizing material utilization, decreasing waste, and fostering material innovation. AI algorithms may analyze data to uncover sustainable sourcing possibilities, environmental friendly material, and efficient production procedures. Tracing the sources of raw material and counterfeit product or fake product is often challengeable in many countries, but with the application of AI, we can address this issue. Even like some brands I have seen, they use this QR code and they employ AI technology to find out which product is a real product or which product is a fake product. So we had some brands that they came to our campus with like different types of product, including fake product. They explained to the students how we can determine the real product and the fake product with the application of AI. In material innovation, I have an example from Bolt Threads. This startup company is very well known for their eco-friendly raw material innovations. They employ AI to create sustainable and environmentally friendly raw materials. The brand utilizes AI algorithms to analyze the molecular composition of natural occurring proteins and generate novel materials with favorable characteristics. One example is microsilk, which is an artificial spider silk produced through the application of AI powder biotechnology. We applied one funding with Deakin University in Geelong to work in AI powder biotechnology from DFED in Australia, but the project was not successful. Then I will discuss about AI applications in fashion retailing. So the chatbots, they have revolutionized the retail experiences by providing personalized shopping assistance to customers. Through advanced algorithms and NLP, chatbots analyze user preferences, browsing history, and purchase patterns to offer tailored product recommendations to consumers. So I have given one example. I'll give the example of Gap in a while. H&M, again, this is a fast fashion brand. They have successfully implemented chatbot to provide personalized shopping experience in retail conditions. My second example on this will be Gap. When I joined here in 2017, Gap invited all RMIT faculty members to go and see the technological developments. Actually, they had digital cameras put all over the stage. So when we worked in the stage, it records the videos, and then when we come down, then we can see different types of garments, different types of like other like anything that you want, fashion accessories, garments, suits. So you can select any type of product that will be best customized to you. So that was long time before. I think that was 2017 to 2019. So that time actually there was not many brands they were working on this technology. But after COVID, I think many of these big brands, they started implementing the technology in Vietnamese fashion manufacturing sector. Okay, coming back to this PowerPoint slide, these chatbots can engage users in natural language conversations, asking about their style preferences, preferred occasions, and budget constraints. Leveraging advanced natural language programming algorithms, the chatbot analyzes responses to recommend clothing items that align with the user's individual taste and requirements. This personalized approach has significantly enhanced user engagement and conversion rates for the fast fashion brand H&M. Then coming to the virtual try-on and personalization, innovative applications of chatbots in fashion retail include the integration of virtual try-on experiences. Brands like Sephora and Ray-Ban have leveraged chatbots equipped with augmented reality or virtual reality technology to enable customers to virtually try on makeup or sunglasses. This makeup belongs to the brand Sephora and sunglasses to the brand Ray-Ban. So this immersive experience allows users to visualize how product will look before making purchase. It enhances the online shopping experience of customers. Then coming to the Claw example, we installed the software Claw that can help like a lot of AI work in the fashion supply chain process. We can create different types of fabric, different types of designs, different types of garment styles, different types of jewelry, all different types of accessories in Claw. Before actually this process was manual and it takes maybe 3 to 4 weeks of time to finalize a specific product. But now with the application of AI, such as Claude, so we can reduce this time from 3 to 4 weeks to 3 or 4 days. It's so quick, and we don't need to prepare the um, designs, or we don't need to really make the product. So everything is done virtually. Yeah, this is an example. Customer is thinking to have some product, and once these customers body is scanned, then they can really see the product, and they can change the look of this product, they can change the design, they can change the style of the product, so they can see, they can design their own product. And this is being offered by many retail stores. Particularly you can find um, like in Singapore, or in even in Malaysia, in the airport, they have this sort of AI assisted designing. So you order when you are leaving the airport, when you come back, you can collect your product from the airport. This is again one application using Claude. So this product is designed by Claude, and we want to apply to the model. So we just select the model, and we just select the product. We just click the model and the product. So it will automatically take the product and apply to the models. So this saves a lot of time, and it is quite cost effective compared to the normal process. You pay the designers, you pay the manufacturers. So everything is eliminated with the support of Claude, which is supported by artificial intelligence. Coming back to the Sephora chatbot, incorporate the augmented reality technology, allowing users to virtual try on makeup products. So without taking a makeup by the customers, so we can see how this makeup is going to fit to our body. By accessing the user's device camera, the chatbot overlays virtual makeup products onto the user's face, providing a realistic preview of the product. I'm just halfway through. Let me see the time, how much time I have. So it's 8:32. I have about half an hour, right? Okay, maybe I'll be a little bit faster. Okay, coming to the virtual try-on. Customers may use virtual try-on technology to see how clothes would appear on them before physically trying them on. So I already explained through the Claude design and then the model. Through the utilization of camera vision and machine learning, AI algorithms possess the capability to analyze body dimensions and suggest suitable sizes for individual shopping experiences. I think the example of gap I already given just some time before. Customers have the option to choose a piece of clothing and utilize the camera on their device to visualize how it would appear on themselves in a virtual manner. So this is done by many global brands, like the large brands in many developed and developing countries. So this virtual try-on feature enables the consumers to visually assess their fit and appearance of the apparel on their own body prior to purchase of these garments. So coming to the next application, it is on tracking the orders and getting the updates about the supply chain of the processing of these orders. So chatbots play a crucial role in providing real-time order tracking and updates, ensuring transparency in the purchasing process. This is an example from Jara. They utilize chatbot to keep customers informed about their orders. Customers can inquire about status of their orders, expected delivery times, and issues related to shipping. So basically, all these applications in order tracking and tracing help to improve the CRM, customer relationship management, and builds the trust of the brand. Coming to instant customer support, chatbots excel at delivering instant customer support and handling a myriad of queries efficiently. This is an example from Asus, a popular online fashion retailer. They employ chatbot for instant customer support. You can ask anything to the chatbot and can get the answer instantly. Then returns and refunds is a major challenge with many fashion brands, many manufacturers. So this process is very complex, but the application of AI or chatbots can streamline this aspect in the customer service process. There are several challenges in customer returns. For example, all these packaging materials, they go into the landfill that create massive challenge for waste management. Then it is a nightmare for the logistics companies. And there may be frauds like wardrobing. Wardrobing means customers buy the product, wear it once, and try to return to the seller and claim for a refund. So this is a common problem in the fashion retailing or on the online selling. This one brand, Nordstrom, so they are well known for their commitment to exceptional customer service. They have successfully implemented chatbot to streamline customer returns and the refunds process. Again, we have been to one of the online suppliers in Vietnam, which is Tiki. So we found they employ a lot of this artificial intelligence to manage their customer returns. These chatbots actually guide the customers through the step-by-step process, how you can return the product and how you can get the refund. This automatic approach has not only reduced the workload of the customers, but also expedited the process of customer queries, resulting in higher customer satisfaction levels. Then the next one is size recommendations. This is again, we find many direct application by leading fast fashion brands and the traditional fashion brands. With the application of chatbots, we can solve the problem of sizing. So different person has got different sizes. You know, the sizes are like small, medium, large, extra large, double XL. So there are a lot of problems when you just go to the retail and buy the product. Sometimes you try a large, but it is maybe not the right size, or sometimes you buy product which is small. So we can get exact suggestion by the application of chatbots in retailing. This example is from Uniqlo, which is a global fashion brand. They use chatbot to assist the customers in determining the right size for different types of clothing items. So chatbot or AI, they save your body measurements and your style preferences. When you next time visit to the store, they give suggestions on your size or your style choices. Yeah, like there are so many different options we can get from this artificial intelligence that will reduce the likelihood of returns due to sizing or styling issues. Then the next section will be focusing on marketing. Fashion marketing using chatbots and artificial intelligence, include employing automated conversational tools and artificial intelligence to enhance consumer interactions, customize shopping experience, and hone marketing strategies. AI studies customer trends, preferences, and behavior. Chatbots, on the other hand, provide real-time customer support, make product recommendations, and simplify online buying. So this basically improves the customer retail experience. So that improves the sales, or that reduces the problems of the people who are involved in marketing of the product. So this is the step-by-step approach, starting from the demand generation in the first phase. Then we go to the first purchase of the customer. Then from the first purchase, we save the data. Then this is being repeated when the customer visit next time. Then we develop loyal customers. Again, if we have some lapsed customers, we can bring them back to this retail store through AI applications. Or if we have some indecisive customers, so we can convince them with the application of AI and chatbots to become the loyal customers of the brand. Then the next one is promotional the campaigns and discounts. So chatbot applications are powerful tools for executing marketing campaigns and promoting discounts. This is one example from Victoria's Secret. This is a renowned brand. I met some people here in Vietnam. So they are primarily involved in lingerie retailing. They utilize a chatbot to send personalized promotion to customers. We had a lot of practical classes by VS people before COVID. I think after COVID, they are not that much helping us to do different types of projects. But again, Victoria's Secret, they utilize AI in conversations with the customers. They understand their preferences and recommend product or promotions according to the consumer preferences. This targeted approach contribute to increase customer engagement and drive sales. Style advice and fashion tips. I think I have covered this in previous slides. Again, I can give some example like the luxury fashion brand Burberry. They have implemented chatbots to provide style advice and fashion tips to their customers. These chatbots engage users in conversations about fashion trends, asking about their preferences and different types of occasions, and they also take the budget into considerations. I think I should skip this because I still have 30 slides. Then the next one is social media integration with chatbot or AI. Chatbots can be seamlessly integrated with social media platforms. They can extend the brand's presence and engagement with the customers. Fashion brands leverage chatbots on platforms like Facebook Messenger or even WhatsApp to interact with customers. So here actually they have a local social media website, which is Jalo, which is very widely used by the Vietnamese customers. So many times I have seen students using this. It's similar to WhatsApp. So they use this Jalo app for selecting different types of product. Then they go through this feedback from other customers, or the word of mouth, electronic word of mouth. Okay, the other example is Tommy, and everybody knows this is an iconic fashion brand. They have integrated chatbot with Facebook Messenger to improve customer experience. Okay, coming to different types of chatbots for fashion applications. So primarily there are four types, but we can say the first two are widely used. So the first one is rule-based chatbots. Then the second one is artificial intelligence powered chatbots. So these two are widely used. Then also we have two more types. The third one is virtual assistant and conversational agents. And the last one is the shared characteristics. Coming to the first type, rule-based chatbots employ established rules and decision trees to generate replies based on keywords or patterns in user input. So I have discussed all these in the beginning. Their benefits stem from their straightforwardness, which simplifies the process of designing and installing them. Additionally, they provide developers with exact authority over the chatbot's actions and ensure consistent and predictable answers. So I have one example here. One of the users is asking to this chatbot, I have a party this weekend. Chatbot, excellent. What kind of gathering is it? For example, informal or formal. User is saying it is an informal gathering. Then chatbot suggestion is understood. What do you think of a fashionable pair of trousers and a fashionable top? Additionally, you may contemplate including accessories such as earrings to enhance your appearance with a stylish flair. Then moving to the second type of chatbots, we have AI powered chatbots. They also employ AI and machine learning to understand and respond to user inputs. They constantly learn and improve performance through data analysis. The benefits of AI-powered chatbots include their ability to handle a wide range of queries, including those that are not expressly coded, their capacity for ongoing learning and adjustment depending on user interaction and data, and their enhanced understanding of context and intent through NLP. This is another example. The user is asking, I need an outfit for a summer wedding. Chatbot, certainly. Could you elucidate your favorite aesthetic and any particular hues or color that appeal to you? User is saying, I like bohemian styles and prefer pastel colors. Chatbot is saying, excellent, excellent selection. Considering your preferences, I suggest opting for a loose-fitting dress adorned with pattern of delicate flowers in soft, light shades. It enhances the bohemian atmosphere and it is ideal for a summer wedding. So we can see how these two types of chatbots are helping the customers to improve their experience, to select their clothing styles or accessory styles for a specific party or specific program. Then the last two types I'll just quickly go through. The next one is virtual assistants and conversational agents. They also can encompass a range of functionalities, and their classification may depend on underlying technology and capabilities. In general, both rule-based and AI-powered chatbots can be considered as types of virtual assistants and conversational agents, depending on their design and functionality. Okay, I think I just go through the last point here. So when for the past time we had Siri, Google Assistant, and Amazon Alexa. They were the prominent virtual assistant applications. So that at that time they were developed using this AI tool. At that time they were extensively used in smartphones, smart speakers, and other devices. And the last one is the shared characteristics. It's similar, but the applications or their objectives are limited compared to the first two. I think again I need to skip a little bit faster. I still have 20 slides. Okay, I'll then go through the benefits of AI applications and the challenges. Coming to the benefits of AI in fashion product development, fashion supply chain. So I have summarized through this slide. The first benefit is vast computation capability. So we can employ artificial intelligence in forecasting, in demand management, because they can do significantly higher amount of calculations considering the past demand, past volume of sales. They can combine the present sales and the present demand forecasting. So they can create more accurate data because of the implementation of AI. Then the next benefit is reduced time. So with AI, we can do several calculations within a short time, and that reduces the lead time. Then we can create novel styles, novel designs, patterns, and silhouette with the past historic data. We can also we can improve the efficiency of the designing process with the implementation of AI. Then it can improve the security in the supply chain process. And with the implementation of AI, we can reduce these cases of fake product in the fashion supply chain process. There are several challenges of AI applications in fashion manufacturing and supply chain process. The first major challenge is cost. For the big fashion brands, cost may not be a challenge, but for small and medium-sized enterprises, this is a big challenge. The cost is a big challenge because they need to invest on buying the software, buying the hardware, and they need some skilled people to run these software. So it is way more expensive for SMEs compared to large fashion brands. And if you compare the cost of the garment, which is super cheap, then when we integrate AI, the cost of the garment may increase. And the question then is, are the consumers ready to pay this increased cost? Maybe many instances, the answer will be no. Then the next challenge is amount of data and quality of the data. In fashion applications, AI need to have a lot of data, implementation of a lot of data, but due to lack of data, AI performance of AI is very poor. So if we need a better performance of AI, we should have a lot of data, lot of training, lot of trials with AI. Challenges with the integration of AI. AI integration with current frequently antiqued legacy systems is challenging and results in data flow bottlenecks. So this is because many times we got traditional systems of doing things that cannot be compatible with the new systems. Then integrating AI becomes a challenge. Scalability, of course, is a challenge. if you compare with electronic sector or other manufacturing sector, there are a lot of challenges for scalability because the garments are very specific to geographic locations. Again, they are very specific to different culture, different society. Yeah, even in the same culture, we have different choices of the consumers. So we have like so many varieties of the product, and producing in larger quantities is not possible by implementing AI. Skill gaps, again, is a major challenge. When we visit to garment industries here in Vietnam, they always complain about students lacking the experience of AI in garment industries. Actually, not many local industries, they implement AI. Only the foreign brands, big brands, they implement AI. That's why we don't find that many skilled labor or skilled staff to work with this AI. There may be job losses. I think everybody knows about this threat. Then bias and inclusivity. So diverse databases are necessary since AI trained on biased historical data that runs the danger of reinforcing negative beauty standards or stereotypes. Then there will be intellectual property rights. So we submitted one journal paper, and we included 3 or 4 pictures that were created by AI. Then the journal mentioned that they cannot publish this AI generated content because there are the intellectual property rights. So either we have to take these images from other sources, or we have to create in like Adobe Photoshop or Adobe Illustrator to create these images. So they did not accept our paper because of these intellectual property rights. Then losing privacy of the data, many times there may be the chances of leaking the data from the consumers or from the buyer. Then the next one is automation versus ingenuity. AI frequently produces variations that requires extensive manual tweaking for final goods because it is unable to match human ingenuity. Then accuracy. AI may generate inaccurate predictions or suggestions which could result in waste or poor designs. Yesterday, I was watching a video like a robot working with one person, and by mistake, the robot missed the distance and just hit the trainer. The trainer was very close to the robot, and the robot cannot predict the distance. So while practicing, it hit the developer itself. So this is like inaccurate prediction by AI. Okay, I think this will be quicker. Case studies from Vietnam. As I mentioned, when I visit to large fashion brands, I find a lot of applications by these leading fashion brands in Vietnam. But when I visit to the local manufacturers, local fashion brands, so there is a lack of application of AI in the manufacturing process. I think this is also the same situation in India. So I'm working with Professor Prabir Jana from NIFT Delhi. He is quite active in AI related project. So we had a discussion about implementing AI in like garment industries in India. So there are still a lot of challenges similar to Vietnam. Okay, in Vietnam, we received some funding to work with the garment industries to see what is the scope of AI or application of technology in garment fashion and garment manufacturing process. Vietnam is becoming a leading global fashion manufacturing country. We received 2 funding from RMIT and from local industries to understand the scope of AI and technology in Vietnamese fashion sector. We found the application of AI is very much limited in particularly in local garment industries. Global leaders such as Adidas, Gap, or Nike, they implement in the entire supply chain process. And in Vietnam, we found only some technologies they are applied in the fashion manufacturing process. So out of these technologies, the CAD system is very common. CAD system include Lectra and Gerber. So these are not using AI. 3D scanning we use for creating the full 360-degree scanning of the body. But again, this scan data should be integrated with the AI software like Claw to generate some impactful data for the customer's body. Similarly, like foot and leg scanning, we can do for shoes and accessories. We can use this sort of scanner to design according to the shape and measurement of the foot. Yeah, this is quite interesting. The virtual 3D garment design using Claw. So they have a lot of artificial intelligence applications and simulations of these. The applications include modular design, 3D simulation, 3D garment edit. You can see from the pictures here how we can edit a specific design, how we can create and edit specific designs. So we start from the mannequins here. Then we create some designs starting from the pattern pieces, and then we make the garment, and we can apply these garments into the mannequins to see the product. Similarly, in selecting trims, fine adjustment of garment, fit analysis, and managing color. So we have a lot of application of Claw AI software in garment industries. Our students also applying this Claw software to manage their product development process. Then these are some of the technologies that we found they are implemented widely in Vietnamese manufacturing industries. One of these is radio frequency identification technology. This technology is limited, again, is limited to some of the industries in Vietnam. They implement RFID in warehouse management, tracing and tracking, in counterfeit or fake product prevention. So I have seen M&S store how they implement this technology to prevent fake product. Then ERP software and lean manufacturing is a common practice in many of the Vietnamese manufacturing units. I'll conclude and then I'll discuss about the opportunities for collaboration. So from these above discussions, we can conclude that there are a lot of potential for AI integration in fashion, starting from design to selling the product to the consumers. When it is considered for the developing countries like Vietnam, there are very less applications of AI and technology in garment manufacturing sector. Only the renowned fashion brands, they implement AI or artificial intelligence or chatbots in the entire supply chain process. The major challenges are cost, in addition to the skill needed to run the software, operational and technological challenges. Maybe in the future, there will be increased use of artificial intelligence in fashion manufacturing, fashion supply chain process. Yeah, this is all about the presentations. So I'll discuss about the collaboration opportunities. As I mentioned before, I am from RMIT Vietnam campus, and we have 3 campuses, one in the north, which is Hanoi, the capital of Vietnam. One in the south, which is Ho Chi Minh City or Saigon South. I am located in Saigon South. And we have another campus in the central province of Vietnam, which is Da Nang. In our School of Communication and Design department, we have 7 programs: digital film and video, digital media, design studies, fashion, where I belong to, games, languages, and professional communication. So out of all these programs, games program, they implement lot of AI applications in designing different types of games. Coming to the some of the current project that we are working includes application of technology like RFID, or we are trying to publish another book on the technology which is already approved by Springer. We are working on developing new materials from recycled product. We are working on CSR, corporate social responsibility. Then we are working on sustainable developments, circular economy, and waste management. And finally, we are working on green fashion supply chain management. So these are some of the recent publications from the funded project. The first paper published from the funded project was Sustainability Benefits of RFID Technology in Vietnamese Fashion Supply Chain. Then also we investigated the blockchain application in the food supply chain, and we published this paper, Adopting Blockchain-Based Traceability in the Food Supply Chain in a Developing Economy, Facilitators and Barriers. So this was based on the data collection from different types of customers in the food supply chain process. Then again, you can see we already published a book. So I have a copy of this book here. So this book extensively covers different AI applications, chatbot applications, technology applications in fashion supply chain. Our focus is to publish Q1 journal papers, book chapters, peer-reviewed conference papers, or we are ready to collaborate for external funding applications like from AICTE or DSTO or any other funding bodies from India. So if any of the faculty members or even student project can be done, so I'm happy to join. But again, we have PhD programs that is fully funded with scholarship by RMIT University. If any of the students want to join in any PhD program, so you can reach to me, and then I can forward your application to the corresponding school. So in RMIT Vietnam, we got 3 different schools. School of Communication and Design, that is my school. Then we have SSET, School of Science, Engineering and Technology. So they have 6 or 7 branches in this, including computer, software programming, electronics, mechatronics, and few others. I don't remember all the names. And then finally, we have School of Business, the School of Business. So 3 schools. If you are from any of these fields and you are interested to join in a PhD program with 100% scholarship, you can approach to me. These are some of the references.
Naik sir, kindly share your contact details also. I think many people will be interested to join you.
Okay. I can type here.
Email address you can send.
Yeah. I'm just looking for to share. I think I cannot chart here. Um, Maybe Nehamam, you can share my email ID to all other staff members or the students. Jagriti, can you share my email ID to all other students?
Sure, sir. I will send it to everyone.
Okay, I think this is the end of my presentation. Now we can open up for question and answers.
Hello, sir. Sir,
Yes, I
I'm
can hear
having
you.
one. Yeah. Actually, I'm Dr. Pooja Dhar, and I'm having one question regarding the use case you discussed about the AR using the in the makeup. Right. So my question is that AR makeup apps capture facial images, facial landmarks, and biometric data. And this data can be misused for identity theft or facial recognition. So my question is that how that security is taken care.
Yeah, that's a good question. Sometimes there is the breach of the data, like Facebook, these hackers steal the data from Facebook. So this can happen with these brands. Um, they have to implement like these, what is it called? These strict systems like the coding, encoding these information from their databases. So they have to implement a strong safety mechanism to protect their data. Even in Facebook, so it's well known, but we have seen sometimes all the consumers' data is being stolen by the hackers. So there are always threats, but they should design some safety measures to protect the consumer data.
Okay, so thank you.
Yes, any other audience participants wants to ask anything? Jagriti and Bhavya, kindly check out. Some message has came that feedback form is not opening. Give open access.
Yes, ma'am. We'll see.
Okay, okay, check it out and then send. The feedback form is open for half
Sir,
an hour.
good evening,
And
sir. My name is Niaz from Crescent University, Chennai.
Yes,
Is it
Nias, I
audible?
can hear you. Can you ask your question?
Sir, can we use AI in VANET networks, vehicle ad hoc networks?
Sorry, which network?
Vehicle ad hoc network for
Um,
controlling the, the traffic, like traffic congestion.
Yeah, I think we can use. We have some people in the School of Science, Engineering and Technology. They did some project with the Vietnamese local traffic authority here. It can be, although like it's a bit technical for me. I never worked this type of project, but I think we can implement this technology for.
Sir,
Um,
okay, sir. Thank you. My
And
another
again,
question is,
again, my one of my
uh,
colleagues will be joining for a talk on 24th. So you can join and ask him. I'll inform that this sort of questions will be there.
okay, okay, sir. Thank you.
Any other questions?
any other question from participant side? Okay, Nayak sir, thank you so much for sparing your valuable time.
It was a great pleasure, Neha ma'am, and thanks, thank you, and thanks Jagriti. Thank all other organizers for this
Sir,
event.
one more thing, Naik sir, and actually our director, sir, director UIT was not able to join the inaugural session. So after that, he called me up and asked me to send regards to you, Professor Ashmi Dhingra.
Thanks. My
Okay.
regards to Professor Dingra.
Okay, I'll send, sir. Thank you so much. Thank you, sir, for sparing time. And all the participants are requested to just open your video for a group photograph. Participants, please. Bhavet, take a photograph.
Okay, ma'am.
Okay, I think it's done.
Done, ma'am.
Done, ma'am.
Okay, okay. Thank you, all of you. And in the next 5 minutes, our next expert will join for a talk. So kindly be on
Thanks
this.
everyone.
Okay, bye, sir. Bye.
Bye bye.
Thank you, sir.
Do I need to stay? Do I need to stay? I can stay to listen the next presenter.
Sure, you can, sir. Definitely, you can, sir.
Okay, okay.
Okay, so feedback form is sent in group. You can fill it. And thank you so much, Professor Rajkishore Nayak, sir, for such an insightful and enlightenment session.
Mm. Yeah, good evening to all. Am I audible to everyone?
So, Jagriti, we have our next speaker, Professor Abhinav Saxena from JC Bose University,
Yes, ma'am.
Faridabad with us. Okay?
Yes, ma'am.
And Professor Rajkishore Naik, sir, is also online with us. So, Jagriti, now you may continue now.
Okay. So, good evening, sir. Our next esteemed speaker is Dr. Abhinav Saxena, sir, an assistant professor in the Department of Electrical Engineering at JC Bose University of Science and Technology, YMCA Faridabad. He holds a PhD in electrical engineering and has more than 12 years of teaching and research experience. His research interest includes AI, machine learning, renewable energy systems, smart grid, and electric vehicles. And he has published over 100 research papers and holds 18 patents and is a senior member of IEEE. So we feel privileged to have Dr. Saxena sir with us. So sir, I kindly request you to take over the session.
Okay. Thank you, Jagrati. First, you confirm me. Am I audible properly?
Yes, sir, you are audible.
Okay, okay, fine. Okay, let me share my screen.
Yes, sir, just a second.
Yeah, I have shared it. So please confirm me.
Yes, sir, it's visible.
Yes, sir, visible.
Can you see this complete slide? Like
Yes, sir,
suppose
complete
if
slide. जी जी जी
I
जी
am
fine
changing the slide, so can you
fine
see it? Na?
changing. हाँ जी हाँ जी.
Yeah, yeah. Okay. So thank you all. So before I start my presentation, I am highly thankful to Professor Neha Khurana ma'am for inviting me for on such a very good platform, and all the organizers of this AICT at ATAL FDP program, Department of Electrical Engineering, MD Rohtak. So my topic for this today's talk is simply like the enhancement uh, in the charge control of electric vehicle system using hardware setup here. So in this one, basically, uh, we discuss about the various charge controlling aspect of an electric vehicle system on a software platform, further followed by a hardware setup. Okay. So on the software platform, we have applied our different algorithms for checking its availability in terms of like its SOC measurement, its voltage profiles. In addition to that, we have also measure the regenerative braking action. Okay, so these are the two major aspects: charge controlling of electric vehicles and the regenerative braking actions. In the charge controlling action, we will also see the charging and discharging aspects. So first, we will analyze it on a software platform, and similarly, the same thing has been analyzed on a hardware setup that we will discuss later here. Okay, so before I discuss about is charge controlling aspects, let's discuss, because more or less we are seeing that from the last few years, our old traditional vehicles has moved on to this EV vehicles due to certain limitations and due to certain drawbacks. So let's see here. So although we know that the issues with the conventional vehicle is like the major issue is this, is it like a carbon emissions here that that causes to be a non-sustainability here. Okay, so at the end, in order to overcome such type of issue, the electric vehicle were used. And additional one more and important part is if we talk about in terms of fuel, especially petrol and diesel. Okay, at present it is quite limited available, but it is a possibility that it will not be available in the future. So in terms of cost of point of view, we can also move on from this conventional drive mechanism to this modern electric vehicle system here. But still, there are certain challenges are associated with the electric vehicle here. The first thing is like the first and the major challenges is purchasing cost. As although we know that the electric vehicle, the major the major part of the electric vehicle is battery. If you see, like if any electric vehicle, so 70 to 80% cost of the electric vehicle is being constituted by this battery here. So since the cost of the battery is very high, which makes its overall cost also increases here. That is one of the major concern here, and it's this over exceeding cost of the EV. It can also goes beyond the budget of each consumer. So this can also affect his purchasing capacity here. Okay, so so purchasing capacity is the major concern of this. You can see the challenges with the electric vehicle. So in my research, especially on the software platform, I have tried to reduce the battery of the I have tried to reduce the cost of the EV battery. That we'll see here. The next thing is the range anxiety. The word, whenever we hear about the anxiety, it means it's things something like depression and all. It's not like that. The AV, the anxiety means the covering distance. Okay. So more or less, if we see like a good vehicles like Toyota and something other like, what in the full charging capacity, this EV can run around about 250 kilometers or 200, 300 kilometers here. So they have particular restrictions over this EV here. So more or less, we are also working on it to increase this covering distance capability here. Okay. Next one is limited selections. More or less, it's not better to see limited selection. But overall, we can have a better chance. We are having a more scope to introduce the more models on the EV, but in terms of the very lesser cost effective. So if you see, limited selection means if we go just a few years back, so you can see like only like some companies like Toyota and Hyundai, they were in fact Mahindra, they were producing their model of EV, but not with the others. But as of now, you can see all the companies are producing the EV model here. But still, they have a very limited stocks. They don't have so much of variety here. Okay, That is, we can say limited selection in the EV. Another challenges with the EV is that if there is any technical issue comes out in the EV, so you have to directly go to the showroom. Okay. Now, if you see like conventional mode, like especially two-stroke vehicle, four-stroke vehicle, you can find a nearby technician to help out to repair our vehicle. But that is not possible with the electric vehicle. That is the challenges with the EV here. Another one is the charging infrastructure. Mostly, if you see, the charging infrastructures are mostly available in the metro regions. They are not available in the remote areas here. Okay, so that is also one of the major charging infrastructure. The government is also planning to install a more number of charging stations so that it can be easily uh, available to consumer. In fact, if you see the high-rise societies, as of now, all the high-rise societies are having a facility of this charging infrastructure here. Okay. The next limitation is the charging speed. Charging. So normally it is found that this EV are supposed to get fully charged within a span of 30 to 40 minutes. Okay, sometimes it has been also reduced to 20 minutes, but still the 20 minutes is too much large. So research is also going on to how we can reduce this charging time here. The next one is grid capacity. It simply provides the total charging spent, the total charging limit of an EV here. Higher the grid capacity, higher the charging probability aspect available for the EV here. The next is again charging price infrastructure. Obvious, the EV cost is higher, so it is directly associated with is more charging prices here. Okay, so more or less, if you see, all the challenges are quite associated with the cost here. The next one is again, if further challenges like charging infrastructures that we have already discussed, grid capacity, peak demands. Peak demands is like it is preferred normally if you see in terms of electrical consumption point of view. So we prefer that during peak hours, especially in the afternoon session, our load requirement must be fulfilled by our renewable energy sources here, especially solar and wind. So wind you find mostly in the coastal areas, but if you find the northern region, the solar is quite dominant, it's easily available. So it's quite preferred to meet the load demand in the peak hours with the help of the solar photovoltaic. Okay, so that is the major requirement. So similarly, we also try to meet because more or less EV charging, okay, the demand of EV charging is quite predominant during peak hours, especially in the afternoon session, especially in the office hours, actually in the morning and the evening, when someone is going to office, when someone is returning from the office, it is expected that at that time, this charging aspect, or basically the charging demand is quite large at that time. Okay, so it is try to prefer to charge that battery with the help of our renewable energy sources that we'll discuss in our further slides here. Okay, but if you see what can be a problem with that, as I told you that the solar EV has a more cost, and you are also introducing a solar photovoltaic, which are also itself having a more cost, but that makes the overall cost to be larger. That can be one of the major concern, that is the cost. But still, in terms of sustainability, in terms of eco-friendly, that is the best solution here. Again, there are more cost infrastructure. Okay, as we have seen, urban planning and permitting, we have to make more policies to set up this EV infrastructure here, charging station managements, and the most important, the last one is, if you see in the persons living in the urban areas, they are highly familiar with the EV, but for those who are residing in the remote areas, I cannot say it's not better to say they are totally unaware, because more or less we are living in the era of social media. People are quite aware of the concept of the EV, but it is expecting that in the comparison to the urban areas, the people in the remote areas having a very lesser awareness. So the best part is to make them aware about the utility and the importance of the electric vehicle here. Okay, that is the major challenges here. Now, what are the benefits? As I have seen, the benefits is like I started with the last 3 points here, and I told it is eco-friendly. It is inevitable because the fuel is always available. It's not like petrol and diesel, which are evitable here. And the last, if you see as I told you that the conventional two-stroke and four-strokes engine, which are based on this petrol and diesel concept, they are producing a lot of carbon emissions, so in the form of carbon monoxide, carbon dioxide, and other hazardous gases, which at the end polluted our environment and causing the non-sustainability. Okay, so that is in order to avoid such issue, we are producing this like the concept of no carbon emission. It is producing no any carbon emission and maintaining sustainability. If you recall, just 2 years back in Delhi, there was a G20 summit was happened with there were delegates of all the most reputed 20 countries will come. The theme of the G20 was Vasudhaiv Kutum. Okay, that was totally based on this sustainability. Okay, so that is why, in lieu of this higher cost of the EV, because we are expecting to having a more better solution in the form of the net zero carbon emission and more sustainability, so we can plan for it. Okay, others benefits, like if you just see their cost is somehow, if you see, the major advantage of EV is that their cost is much less as compared to especially with the gasoline, means like CNG and LPG. Okay, so more or less it is also that an electric vehicle typically costs around 50 to 70% less in the fuel and maintenance as compared to the gasoline one. Okay, same for the other one type. These are totally other benefits are like, if you see, as I told you that if you see like in this one, just a second. Yeah, just confirm me whether the slide is visible or not. Jagrati, please confirm me.
Yes. Sir, it's visible.
Okay. Is it changing now? I think it's not changing. Yeah, just a second. I think it is visible now. It's changing.
Yes, sir.
Okay, fine. So as what I was saying that if I compare the benefits of this electric vehicle here, so this we have already discussed in the previous slide. So if we charge this, if I want to compare this annual carbon emission produced by each vehicles, normally if you consider the first one, that is gasoline vehicle, that is our conventional CNG level here, because you can see like it is producing your amount of 90 to 100 lbs carbon dioxide, followed by the 20 lbs nitrous oxide and 1.5 lbs PM here. Okay, So if I compare with this the electric vehicle which is charged with the grid here, so you can see the level of carbon dioxide has been reduced a lot in comparison to the existing one. It has been reduced from 9200 to 3000, save for nitrous oxide. But still there are some amount of carbon dioxide are present here. But if I charge this electric vehicle with this renewable energy, especially with solar, you can find out this is totally a sustainable solution here. You are not expecting any type of carbon dioxide, any type of hazardous gases. It means we can have a better health here in terms of zero carbon dioxide gas and all the with zero gas here. Okay. So again, we have this various charging level of this EV here. So if I see we have different level like AC level 1, AC level 2, and AC level 3. Sorry, AC level 1, AC level 2, and DC fast charging. So more or less in the today's scenario, the DC fast charging is the most popular as compared to the AC level 1 and AC level 2. Because as here you can see, the AC level 1 has a charging limit of up to for this load of 1.4 to 1.9 kilowatt. But for the level 2, it has been enhanced from 2.45 to 19.4. But if you see the charging time for the AC level 1, it is like it charge like for 3 to 5 miles for the 1 hour. And for this level 2 here, you find out it is for like 10 to 20 miles of range per hour. But still these are not so much sufficient of this more. It is the more charging time here. So if I consider it for DC fast charging here, so you can find out this overall charging time has been reduced to 20 to 30 minutes. So that is what DC fast charging is preferred in comparison to AC level 1 and AC level 2. Okay. So if I go in further the designing part here, that AC level 1 and level 2 AC charging. So there simply we have an example like here you can see the electric vehicle have a regular outlet for level 1 charging. Here you can see like it is a standard plug like J1772 Tesla plug here. Okay, so it means 1 Tesla we are using for one plug here. Further for the if I check it out for the DC fast charging, so you can see many DC fast charging stations are using the special type of plug. These are basically CCS and Chamdo plugs here. Okay, so again it is like a 1 Tesla is used like a 1 Tesla plug here. Okay, so we are using these 3 specs here for the better fast charging here. Now, as I told you in the beginning, my research is involved in the 2 different ways. First, I am analyze the things on a software platform, then the hardware assessment. On the software platform, I performed the 4 tasks. Okay, the first like the development of solar photovoltaic cell, because I simply like the charging of this solar photovoltaic, charging of the EV has been done with the solar photovoltaic. Thereafter, the battery assessment in terms of battery size, battery price, and total battery arrangement with the help of genetic algorithm has been done. Okay, as I told you in the beginning, the battery cost, higher battery cost is the major concern with the EV here. So I try to reduce this battery size here. If I reduce the battery size, so more or less I can say the battery cost will reduce. So that has been done with the help of the G here. Another one is which is related with this second objective. It is like the risk analysis for the enhancing the life expectancy of the battery here. Use the help of the genetic algorithm. The last one is regenerative braking actions. Okay. So further I begin with like. So my first objective I see here you can see like this EV is getting charged from the 2 way. First it is getting power P1 from the solar photovoltaic and the power P2 from the battery energy storage system. So we know that the output of the solar photovoltaic cannot directly charge the EV. So we need a power to X converter in between them. So I've connected a boost converter and DC-DC converter between the solar photovoltaic and the EV here. Okay, and further, the other source, that is battery energy source system, the DC-DC converter has been connected between them. These two DC-DC converters are basically buck boost converter. So in the boost converter, which is just connected nearby to the solar photovoltaic, it is being getting a switching pulses with the help of this MPPT, that is maximum power extraction from the solar photovoltaic cell, and with the support of part-time and observed algorithm. Thereafter, the DC-DC converter is getting a switching pulse from this heuristic Lyapunov fuzzy energy controller. And thereafter, again, the same thing has been done with the DC-DC converter with the BSS. Okay. Let's begin with. So as here you can see, I told you that DC, this is the configuration of DC-DC converter, which is connected between solar photovoltaic cell and the EV. So this is like, you can see, it is having a two switches, J1 and J2 here. Okay, so by considering this J1 and J2 here, and the diode, it is having a J1, J2 normal switches, and we have like 4 power tronic switches and 4 uncontrollable diode. Okay, so on the, by considering this 4 various aspects, there are 4 operations are possible. Okay, so accordingly we have developed this one here. Further, the BSS is getting the power from this, is providing the power, but the DC-DC converter, which is just connected nearby to the DC-DC converter, which is just connected between the BSS and EV, it is getting a switching pulses in the different stages. It begins with like in the stage 1. Initially, the power is coming out from the solar photovoltaic and is passing to PI controller, and it is generating a not an S1 switching pulses, because we have a 6 switching pulses there. Further, this battery voltage in the stage 2, the battery voltage is compared with its reference value and is passing to PI controller, which is again producing a reference current here, and the reference current has been compared with this measured current, and the output is passing to PI controller. And thereafter you can see we are using equalizers. Okay, and then equalizers and comparators are involved with our SR flip-flop. Thereafter, its output is generating the PWM signals for S1 and S0 here. Same in the stage 3, the current has been compared with its reference value, and the output is PI controller passing to PI controller, and this further it is generating a S0 and S1. So as we have 6 switches, and the 6 switches is getting up switching pulses from the 3 stages here. Again, it is a mathematical modeling of solar photovoltaic. This is the standard equation of solar photovoltaic, as you can see, like as everyone knows here. Now, let's come to second objective. As I told you that we have to reduce the battery cost, so and the battery size. So in this one, what I did, I have developed an objective function in terms of battery size, number of batteries, battery price, and SOC. Normally, we know that SOC is called state of charge, which is defined as the ratio of the remaining capacity to the total capacity, total available capacity, or total capacity. Okay, but here it has been delivered. It has been taken as a difference between the power generated by the solar and this load power here. Okay, so these 4 parameters have been considered in developing the objective function. So again, this objective function has been, you can see, this has been. So again, the objective function has been developed in this empirical form here. As here you can see, it is like E into N. This is developed from my side here. E is called to battery size here, and N is called to be as the number of batteries. Q is the charge, as we know that. Okay, so accordingly, this objective functions has been developed. Okay, from my side, and I have considered the 3 unknown parameters, because others are more or less quietly known as, that is K1, K2, K3. These are unknown variables which are supposed to be trained with the help of genetic algorithm here. Okay, and N is the number of battery size here, number of batteries. So what we have to see, suppose if we have total, in this case, I have taken the 8 batteries, total 8 batteries. So it is up to us what type of configuration that we can take. Either it can be like 8 batteries in a row, that is a one row and 8 column. Same for 8 batteries in a column, means one column, 8 rows here. Sorry, one row, 8 column. It is like that. Some it can also be arranged like 4 into 2, 8, we have seen 8 into 1, 1 into 8, 4 into 2, 2 into 4. So various arrangements of battery are possible with that. So we have to see which arrangement of the battery is providing the least cost of the battery and least size here. Okay. So that has been supposed to be considered with the help of this objective function here. So as I told you that the known variables are trained with the help of genetic algorithm. So there are 3 major steps of genetic algorithm. Is like reproduction, crossover, mutations. These will be applied in the objective function for its assessment here. So if I want to elaborate more, so earlier was the this objective function that was considered for the battery size. Now we have developed another objective function for this battery cost. So in this one, I have taken the K4, K5, K6 are the cost factor in terms of dollar per kilowatt hour. Again, these are trained with the help of this our algorithm here. Okay. So again, the other parameters are known that we have already discussed. There's E the this energy here, and is number of batteries, like that. Okay. So after analyzing this one, we have seen the battery size. As I told you that we have total 8 batteries. So these are on the left hand side. Here you can see we have the various configurations of the battery. For the 8 batteries, it is 1 by 8, 8 by 1, 4 by 2, 2 by 4, or 4 by 4. So according to various battery arrangement, we have find out the overall battery size. So you can see the least battery size is coming out with this 4 by 4 battery configuration. It means if I'm using 4 rows and 4 column, it means we can say like it is the best battery arrangement, or because we are getting a least battery size here. Okay. Further, similarly, we have find out the same thing for battery cost for the various battery configurations. So we find out there is 4 by 4 battery arrangement is providing a least battery cost that has been attained with the support of this genetic algorithm. So it is coming out to around 0.84, and which was lesser as compared to the 0.99 which we are getting from the conventional method. Likewise for other methods, likewise for other arrangement, we are getting a more battery size. Like for 1 by 8, we are getting 1.22. For 8 by 1, we are getting 0.9. But the least battery price we are getting with the 4 by 4 battery arrangement here. Okay. So as we have seen that the least battery size and the least battery price we are getting with 4 by 4 battery arrangement here. Further, I have checked the life expectancy, that is a risk factor. Because we are dealing with a battery, each battery is having a certain life period. Okay, that life expectancy can be measured in terms of a risk factor. And that has been mathematically considered in terms of the minimum desired kilowatt hour divided by rated kilowatt hour into number of batteries there. So again, I find out this risk factor for the various battery arrangement under different loading conditions. So what I find out, you can see like again the least risk factor is coming out with a 4 by 4 arrangement with the support of genetic algorithm here in comparison to the existing one. So this is how the dominance of the genetic algorithm plays here. So here it is like the 4 by 4 battery arrangement here, which is providing the least battery cost, least battery size, and the least factor here. Okay, so this was the part we have discussed. Again, if I want to do the modeling of electric vehicle, so we find out this modeling of electric vehicle has been this has been developed from my side. So I consider the various parameters of this EV. According, these equations have been designed. Whether you can see like this over here. Okay. Now, if you see the denominator part, sorry, if you see the bottom part of this slide, I have taken the SOC for the charging as well as discharging here. For the charging level, if you see the SOC, it is like SOC initial charging. It is simply like First, we have considered its initial condition. Thereafter, we have considered its present value of SOC and what is the past value. Same thing, we have considered the SOC for the discharging level here. This has been also considered for its initial time as well as present and past time. So it is observed that the power transmitting from electric vehicle to grid, it is like the overall charging SOC minus VI discharge SOC here. Okay. Again, the process of the charging we have discussed. So we have measured this voltage level for the various level of charging. For the half battery charging, we are getting this voltage around 1 volt. So again, you can see that we have two prospects of the power transferring. Overall, in the software mode, we find out the power is the transmitting from grid to EV. We are getting positive 500 watt. But when we have power is going revert back from EV to grid, it is something around minus 500 watt here. Okay. So if you compare like the saving in power, so we find out the saving in power is more. It has been reduced as the voltage level increases here. Similarly, say for the waiting time, say for the time to reach in plug here. So it means as the voltage level increases, which means the capacity of the EV if increases, so we can look for the more saving power, the more waiting time, and the more time to reach in plug here. So again, this is the last part of the software, the regenerating action here. So again, you can see like the output of this solar photovoltaic is given, and we did for MPPT analysis, and this further going. In this one, we have used the DC motor here in the software part for the regenerating actions here. Okay. So how I did here? So the regenerating actions is assessed with our LQR controller here. Okay, so here you can see the voltage, this measured voltage is compared with this reference voltage, and this comparison is passed through a certain gain, and that gain has been just a minute. Yeah, am I audible to you? Yeah, somebody please confirm me. Am I audible?
Yes, you are audible now.
Right. So in this one,
Audible.
Yeah, thank you, M. So as I was discussing, like in this one, the difference between the measured value and the reference value is passing to certain gain, and that gain has been further. It is like G and H here. They have been further sum up and providing a change in derivative of change in speed. And after that, we are providing integrator, and this further compare with the reference value, we are getting this measured value of speed, and is passing through a high pass filter here. Okay. Thereafter, if you see in the this bottom part, we have make this LQR controller here. So this LQR controller is basically consist of mainly a K dash part here. The designing of K dash part in this one is the key role over here. Okay. The suitable value of the K dash has been selected here. Accordingly, this so that the regenerating actions can be possible. Earlier was the LQR controller. Now we have taken the LQR based fuzzy logic controller. The overall structure is same, but what we did, we have simply did a certain modification on this one. The high pass filter has been replaced with this fuzzy logic controller here. So if you find out that this change in speed and rate of change in speed are the inputs of the fuzzy logic controller, because we know that the inputs of the fuzzy logic controllers are basically the uncertainty. They are like the form of error, change in error. So we have taken the two inputs like the rate of change in error and this change in error here. After the output is again speed, and which is further part which is again for passing through a LQR controller here. Thereafter, it is observed that the certain parameters without LQR and with LQR here, and with LQR based physiologic control. So you can find out the torque in all the cases are found to be negative, because we know that in the regenerating actions, the torque is coming out to be negative. So that is assured that our regenerative actions is occurring here. But we find out that the LQR based physiologic controller is providing the better result, because in terms of the least transient and the least overshoot and the lesser settling time, in comparison to this LQR and without LQR part here. Further, if you see, if I compare the efficiency and the power saving, so you can find out the power saving, because this is totally energized with the help of this solar photovoltaic cell here. So you can find out the power saving is too much, is quite larger with this LQR with physiology controller. It is like 24, that is around 24% approx, in comparison to 11.9. It means we are having a more power saving. Similarly, for the other irradiations, we can see like 22.6 power savings we are having in comparison to 12.6. Similarly, for the efficiency, we are having a more efficiency with the LQR based physiological controller in comparison to the conventional one. So this is how the LQR based physiological controller is predominant here. This is the future of electric vehicle here. Okay. Now let's come to the hardware part. So overall, we have seen this. Till now, we have seen the software analysis of the charging and discharging of electric vehicle along with the regenerative reactions. Now, in the hardware part, similar kind of things are being analyzed, but here certain configurations approach has been changed up. Okay, because the hardware and, as you know, the hardware and software both are different aspects. Okay, you cannot meet the results of hardware and software. Somehow it can be meet. But in this one, what I did, as I can see, like, if you see the structure, this structure, I'll show you this hardware part, this one, in the next slide. Before that, let's try to understand this one here. This is my EV battery here. Okay. This EV battery is getting charged from this available grid here. Okay. How? Now we have this available three-phase supply of this 414 50 Hz supply available with us, which helps to charge our EV battery, which is having capacity of 72 watt and 100 Ah, 100 ampere hour. Okay, so this grid is supplying power to the EV with the help of this MCB, that is major circuit breaker, and with certain filters, that is LCL filters we have taken. Thereafter, we have used the grid side converter here. So grid side converter is simply converting your AC to DC here. And again, since it is a controlled rectifier, so we need to provide a certain switching pulses that we'll see. But that switching pulses is being provided with the help of the FOC, that is field oriented control here. Okay, we have that FOC helps to providing the gate pulses here for the switching of this GSC. Further, the output of the GSC is stored in the battery, that is capacitor here, and across which a certain voltage level has been measured. Thereafter, that stored charge is supplied to the DC-DC converter here. Then the DC-DC converter is simply a buck boost converter. It's not like a simple buck converter. It is a buck boost converter here. Okay. So according to the voltage has been adjusted. Now, thereafter, we have taken the inductor. We have taken the 3 inductor. Each inductor is having a rating of 1.5 millihenry to 1.5 millihenry and a current of 1.5 ampere. Further, we have taken this MCB here. So in this one, you will see like I have taken total here 3 MCBs here. The other MCB I will be shown in the next further slides here. So this is how you can see the grid is supplying power to this EV with the help of this GSC and DC-DC converter here. Now again, as I told you that this grid side converter and as well as this DC-DC converter, they are giving us switching pulses with the help of FOC, that is field oriented control. Okay. So again, the question is how this FOC has been developed. So for this, what we did, this FOC has been developed on this MATLAB platform, especially in the simulating mode. Okay. So after that, once this algorithm or this technique has been developed on this and is the standard software, Thereafter, it has been interfaced with the real-time system. Okay, and that interfacing part has been done with the help of our controller. It is called to be a BAVE ACT suit controller. Okay, as here you can see in this one, this BAVE ACT controller, it is being interfaced with our system here. Okay, that will show in the next slide. You can see over here this BAVE ACT suit controller. It is receiving a signal in the form of the voltage and current, and thereafter it is producing the PWM pulses here. Okay. Now let's see how it is being implemented in the hardware one. So here you can see this is my hardware setup. Okay. So in this one you can see like this yellow wire you can see. We have a lot of pictures. This is the best pictures of this my setup here. This yellow wire is coming out from this computer's desktop. This is the BAVE ECT controller here. Okay. BAVE ECT suit controller. So what it is doing, we have developed an algorithm on this software, and after that, this yellow wire connector is providing the signal to BAVE ECT controller. So here you can see this BAVE ECT controller has 16 signals, and the output of this BAVE ECT controller is providing. It helps to switch our controllers here. It helps to provide the switching pulses. So you can see how many switching pulses we have, how many converters we have. So as I told you in the beginning, in the previous slide, we have a grid side converter and this DC-DC converter, because first we are considering the aspect for the charging and discharging, because I told you that we have to consider the charging and discharging and the regenerating actions. So charging and discharging has been directly from charging and discharging has been done from this grid directly. So this is my this three-phase grid supply, 415 volt 50 hertz supply. Now what it is doing, this is again being transformed to this grid side converter. The power is going from this grid to this. I know it is difficult to explain over here because there are a lot of wire and connections available, but I'll try to explain it in a very easy form. This switch is providing this three-phase supply is providing the power to this grid side converter with the help of this LCL. Here you can see we have this three filters, LCL filters here. After the LCL filter, this grid side converter is receiving the power here. Okay. Now after getting this receiving the grid power, this grid side converter, it will be activated only, as I told you, that once it receives a suitable amount of the switching pulses. So as here you can see, the 3 wire of this grid side converter is getting a signal from this BAVE ECT suit controller. Okay. So after once this BAVE ECT controller is receiving a signal, receiving an input from this system through this interfacing setup, it is providing this PWM pulses to this grid side converter here. Okay. And further, once this grid side converter has received the PWM signals here, it comes into the on state. Once it comes to on state, it starts delivering the power to this. Here you can see the battery side in the last one. You can see this is the electric vehicle battery. And at the end, you can see the black one is the EV battery, which has to be charged. And the converter which is connected nearby to the battery is called DC-DC battery side DC-DC converter here. So this grid side converter is directly delivering the power to this battery side DC-DC converter. And thereafter, the output of the battery side DC-DC converter, it helps to charge this battery here. Once this battery is getting charged fully, after that, it can be a possibility that we can switch off the main MCB. Thereafter, this battery it can come into the discharging mode. How? Initially, the power is coming out from this grid end to this EV. Okay, that is grid to EV. that is the charging state. But in the discharging state, the power can revert back from the EV to the grid here. Okay. Again, in the same way, first is passing through this battery side DC-DC converter. Thereafter, that during discharging, the power is coming out from battery to DC-DC, battery side DC converter. Thereafter, it is going back to this grid side converter here. Thereafter, further, this grid side converter power is going back to the MCB here. So these two converters, grid side converter and this battery side converter, helps to this charging and discharging. But what about if you can see we have more converters? The first converter, we have load side converters and this EV drive converter. Here you can see, because here you can see at the bottom side, here you can see we have taken the two machines, the two machines which are placed on the surface. The first one is called PMSG, next one is called induction machine. Okay, so what we did, one PMSG machine is fixed. The other, because these two are coupling machines, we have two options. Either one PMSG is coupled with another PMSG. The second option is one PMSG can be coupled to induction motor. It's up to us. So normally we know that BLDC motor is used, but in our case PMSG motor has been used, but a PMSG machine has been used, which is providing somehow adequate result here. So as I told you, for this operating actions, especially for regenerative actions and this motoring actions, we are using the PMSG to PMSG operations or PMSG to induction motor operations. So there is a certain connector is available here that can move, that can switch from another PMSG to the induction motor here. Okay, so this will be simply helps with the drive mechanism here. Further, what next? You can see over here, this is a load side converter I have taken. This is the load side converter is again connected nearby to this drive mechanism, and further we can see have this another EV drive converter which is further nearby connected to it. And we know that when such a big arrangement, large arrangement is available, which is providing, which consists of a very current in the order of 3 ampere, 4 ampere, so we need to provide a certain cooling arrangement, because we know that these Paul Torres converters are basically have a certain heat dissipation. So in order to provide a certain cooling arrangement, you can see we have placed a certain fence. That fence will help to provide a certain cooling and maintain the temperature with all the Paul Torres converter here. So this is the complete hardware setup of my EV system. Now let's discuss each block here one by one. This is another view. There's an interfacing between software and hardware setup here. As I told you, this is the PC here. Okay, this PC is being interfaced with this BAFE ECT suite controller here, which is providing this real-time signal here. After that, once the interfacing is been done, this BAFE ECT suite controller is providing switching pulses to the other Paul Torres converter here. Once each individual Paul Torres converter is getting a switching pulses, so we can say this will come into the activation mode. Okay, according to the battery started charging there. Again, it is as I have already discussed, this is the BAFE ECT suite controller, which is providing the interfacing between the EV and the grid, and especially for this electric drive converter. Now we can see this one. As I told you, this is the electric drive converter, which is mainly used for motoring and regenerative braking action of the EV here. Okay, and the nearby you can see like the circular part, the circular shape element is a cooler or is a fan, which is providing, which helps this, which providing the cooling arrangement by maintaining this temperature here. Now let's discuss something more about our BAFE ECT suite controller, which helps for this interfacing and providing the gate pulses here. So as you can see, the BAFE ECT suite controller having a certain operations. It is like for controller management, data logging, measuring, analysis, controller tuning, programming. There are different operations that is being performed with the BAFE ECT suite controller. Basically, if you see, like, it is a comprehensive real-time test framework controller that provides, again, I told you it as for programming. Programming, you can say that it can be a simulating operations, controlling, tuning, analysis, measurement, data logging, control management, for performing the real-time setup here. Basically, if you see, like, it is the interaction between the real-time control functions over the library sort. It is a WC library, is the basic library of this Wave ACD suite controller, which is having a port like iRaster, iTap, probe. And normally, what we did, we connected with the Wave ACD suite controller for this dedicated gigabit Ethernet surface here. Okay. Let's see further here. So here you can see there are certain because initially before interfacing we need to launch this Wave ACD suite controller. So what here you can see on the right hand side, first see the right hand side, this because what we did first, the program has been developed on the MATLAB. After this development of the program of Simulink, we have developed a Simulink. After designing the Simulink of the MATLAB, the Wave ACD suite has been launched, because first it will call that program. Once after calling that program, it will launch. Once it is launched, it means we can say our interfacing has been done. Thereafter, we can see certain signals. It will show like this. We can say like the Wave ACD is giving a voltage like 243 volt, like 19 volt. It's a generalized case. Okay. Now we will see the certain features of this Wave ACD, because we will not have so much of time. So let's discuss in very short. It has certain features. The first one is input register. It can have like 64 input register for online tuning. It can have the 10 samples per seconds. It can synchronize the initial register value for controlling minimum and maximum value. The main thing is, if you see, is dashboard widget like text, field, slider. These options are available. Other like the probe software. It is like up to 128 probe for display, plot, measure. Basically, this soft port is basically like the outcomes in the form of displaying how the output can be presented in the form of display. It can be plot, it can be measurement, it can be for logging. Normally, the prod which is connecting here, it takes like 400 kbps sample rate, and if we are using this buffer depth, it takes like 1 second to 30 seconds per buffer depth there. Okay, these are certain features with this WACD. If we talk about this soft port here, so this Wave ACD suite controller is basically like controlling functions of memory like up to 8 itables here. Itables can be like, we can see, we can edit it, something like that. The major part is like, if you see something like that, if someone has done on the part of machine, especially the Python, most of the files, especially in the machine learning part, when we do when we develop any machine learning algorithm in the Python, so most of the file support with the .csv. So same with this one also. Okay, but this Wave ACD controller supports the .csv file instead of .m file or .any MATLAB file here. So what you can see, we can again further features are, we can see like time plots. It has the 32 number of time plots with up to 8 signal per plots here. It means overall we can see like around 256 signals. Okay, it can consider. It can use the line, dot, step, dot plot. It has a time scaling from 100 microsecond to hour. Time cursors, we have like input cursors, a lot of available. On the y-axis, we can adjust its magnitude like auto scales, manual scales, individual, group options. Okay. Now further, as I told you that you can figure out, you can save the figure plot to CSV, and further, and you can plot the figure to PNG. The plot will be considered in the form of CSV file, and this figure the data will be considered in the form of CSV file. But what if you're considering the figure, that figure can be considered in the form of the PNG. So these two are aspects. Data can be taken in the form of CSV, and the figure can be taken in the form of the PNG here. Okay. The next part is the general plots. We know that is like the X versus Y plot. It has 32 number of general plots, 8 signal that we have already seen. Like it can take total 256 slot here. Next one we have FFT panel. FFT means fast Fourier panel. It means it can measure the THD, the amount of harmonics present in a signal. So this FFT panel will help to check its harmonics level here. Further, we have a power panel, power analyzer, energy levels, data logging, control management function, dashboard, and all. So these all were the features of this our BEV ACD suit controller, which was providing the gate pulses and which was interfaced with our real-time system here. Okay. Now further, if you can see our grid side converter and load side converter, as you can see, the grid side converter is connected in between the grid and the electric vehicle. And the load side converter it means the load side converter means it is like the load. It will be connected nearby the load. Our load is what? The motor. That is PMSG motor here. First, it's not better to say PMSG motor because generating motor different. It means our PMSG will be coupled with the other motor here. Okay. We know that the motor can be driven with the help of the generator here. It means that load side converter, which is connected nearby to this generating actions, it can be work out. So again, this it can be coupled. It can help to regulate this output here. Okay. So as here you can see, in each converter, you can see we have the three signals. You can see like PWM 1718, PWM 1920, PWM 2122. It means it is receiving the gate pulses from BEV ECT suit controller from the same 1718 switch terminal of the BEV ECT. These are fixed here. Same for 1920, same for 2021. Okay. So it is fixed. And each switching pulse is having a polarity, like one is for positive one, next one is for the negative one here. Okay. So if we see the EV charging and discharging aspects, as we have seen, like I think this is already discussed here. This EV charging infrastructure is very based on number of renewable energy sources. In this case, we have not used any renewable sources. This is simply a conventional traditional source. But the main part is you can see the grid side converter and DC-DC converter. These two are bidirectional converters because these bidirectional converters. Why I call it the bidirectional converter? Because it providing the one way of power for the EV charging, another way of power in the opposite direction in the during discharging. That is called bidirectional buck boost converter and bidirectional grid converter here. Okay. Further, if you see the way to switch on this grid side converter and how we are providing this gate pulses here, so this is a certain FOC algorithm here. Likewise, we have measured this VD, that is the voltage in direct axis form. Because again, what basically we are doing, if you see in the bottom part here, first we are measuring the voltage from the grid end. That has been further converted to the EBC to DQ with the help of Clark and Park transformation, as you know that. After transforming from ABC to DQ with the help of Clark and Park transformation, these are passing through your respective PI controllers. Okay. Then this PI controller is been tuned. After that, this VD, IDJ reference value and this omega L. These are standard equations here. And these are passed. In all the equations, you can see like the measured value is compared with the reference value and the output is passing to PI controller here. And thereafter, you see at the end, after developing this one, we are getting VD and VQ. Thereafter, we have applied further inverse Park and inverse Clark transformation, which is again providing the reference value of EBC here. So after that, it is this reference value is passing through PWM generator here, and this once this we know that the reference value is passing through PWM generator, it is compared with this carrier signal and generates the PWM signal set. This is how this gate side converter is being tuned here. Next thing again same, the EV battery charging discharging setup. So what we did here, we have taken this constant current charger has been implemented for this battery pack, which is basically again a bidirectional DC-DC converter here, which will again convert your battery voltage level to a DC link, as shown. You can see like Here in this one, what is this charging level is been converted. The battery, this power stored in this battery has been converted to this certain level here. Okay. So if you see this hardware set overall settings here, these are certain specifications of this my hardware setup. As I told you that gauge specification is 41 volt. Uh, the grid rating is 41 volt, 50 hertz. And further, if you see the grid set converter configuration, basically normally we have used the IGBT based power converters here. Those IGBT based power converters are using the rectifier, choppers, and inverter. And these rectifiers is basically are using this rectifier having a rating of 41580 volt, output is 560 DC, 45 ampere. Chopper is like a 600 volt DC input, 300 volt DC output. Likewise, 2 kilohertz switching frequency we have taken. The maximum switching frequency we have taken up to 20 kilohertz here. And the module of this power tonics converter is your like 1 by SKD 160 by 18 module. Certain because we have taken a lot of power tonics converter here. Okay. Again, for the grid side converter, we have taken active filter of the rating of 7.5 millihenry per phase, 15 ampere, capacitive filter of 3.15 microfarad per phase, 415 volt. In the other way, bidirectional DC converter for the battery is like, again, I have taken IGBT based DC converter, same thing which we have discussed. And the most important part is the type of battery. Again, we will know that most popular is the lithium ion battery in India we use, because it has the major concern of this the lithium-ion battery is because it is having a high energy density. It is high energy density lithium-ion battery has been considered. So the rating of this lithium-ion battery is like 7.3 kilowatt hour, 100 ampere hour, 73.6 volt with BMS here. As I told you in the beginning, from the hardware setup, we are providing a certain cooling arrangement to maintain the temperature. So this is basically the type of cooling arrangement is called to be we have used a forced air cooling. Forced air cooling is basically like it can impose certain restrictions to maintain a temperature. It can provide a certain cooling arrangement so the temperature can be maintained here. The another aspect is like the discharging and charging of EV to three-phase grid. Like it is again the configuration that we have already discussed here. Now let's see certain outputs here. Okay. So, as I told you that the grid side panel has been connected. In the grid side panel, we have like the grid side converters and the DC-DC converter. So here you can see the output of this charging and discharging available here. The DC link which is connected, it has been stored. It has been set at 630 volt here. Accordingly, after setting this 630 volt here, we are getting the per phase grid output is like 4.56 RMS value approximately. Okay. Further, we can see like the battery voltage is set at like 87.59 volt here. Accordingly, we are getting this voltage here. Okay. Because you can see the straight line in this battery, which means we are getting almost a pure DC over here. The power measurement, you can see like if we are taking, you can see like the power which we are getting minus 8.21 kilowatt. It's a real active power here, and the reactive power is 0.52 kV here. Normally, if we are getting both power positive, it means we can say my battery is getting charged with the help of grid. If one power is, especially the active power, is coming out to negative, we can say it is in the discharging mode here. It means power is transferring in the reverse mode here. Okay. So another way is like we can say it is more or less same here. The EV charging infrastructure here. So again, we are getting more or less the same results here. Again, so this thing we have seen like the charging and discharging. The positive power means positive real power, and reactive power means our battery is getting charged. If the real power is coming out to be negative, we can say it is in the discharging mode here. Okay. Now further, if we talk in terms of drive mechanism, so in the drive mechanism here you can see like this is our drive converter here. Okay. Now further, these, as I told you that you can see there are three motors here, three machines. the blue color machine is basically indicating the PMSG. The other two is also, one is PMSG, next one is the induction motor. Okay, so there are two possibility that blue PMSG is fixed, but we have to choose another one. So either you can see one PMSG is connected with the another PMSG, or the one PMSG connected with the another one PMSG with the induction motor. There are there are options available. You can see like we have a pedal. It is basically pedal, or better to say it is a accelerator, just like in the car here. In the car, what we do here, when we accelerate, what we observe, our speed is increasing here, and torque we cannot see it. But in this one, we can check it. If I accelerate here, I can find out the speed is increasing up to certain range. But it is observed that when the speed exceeding its rated value, the torque can comes out to be negative. It means we can see the regenerating action is occurring here. Okay. Further, if you see the EV load emulator, if I see here in this EV load emulator, so what I can see, like as I told you, that this battery arrangement is simply like for integrated with this propulsion drive. Propulsion drive is basically like a PMSG drive here, and this is integrated with this propulsion motor. This propulsion motor can be your this induction motor as well as your this PMSG motor, PMSG motor. It's up to us. Okay. After that, the output of this one is connected with the inverter and the fed side converter. Again, you can, this real-time controller is basically the BEV ACT suit controller here, which is again you can see receiving the signals. First, it is receiving the signals in the form of this three-phase side. Next, it is receiving the signals from the speed and torque here. So here you can see like this BEV ACT controller is receiving a signal, VABC three-phase signal, speed and torque from this shaft here. And after that, it is also receiving a signals from the battery voltage. So here you can see it is receiving a multiple input signals. After that, receiving the signal, the algo is developed and it is providing the PWM signals for this propulsion drive converters and this load emulator converters. Okay, in the load emulator converters, as you can see, we have taken the EM, we have taken like the again DC-DC converters here and this electric drive converter here. Okay, so as here you can see, this EV PMSM drive consists of lithium-ion battery, DC-DC converter, converter for PMSM motor drive for resolving 3 kilowatt, 3000 RPM. And as I told you that this lithium-ion battery is around 73.6 volt, 100 ampere hour as a source for PMSM drive. The battery pack is having a BMS along with a CAN communication. By using this CAN, we can have this battery data like voltage, current, SOC we can measure. Another thing is we have discussed like the DC-DC converter is a bidirectional that can use for, again we can see like bidirectional loading of EV PMSM, motoring as well as regenerating. Okay, since the motor is of motor rating is 72 volt and the battery is 73.6 volt during motoring actions, the buckboard mode and regenerating actions also. And the speed control of PMSM machine is done with the help of FOC controller. One thing I would like to tell you that here I told you that there are two operations that are possible. Like in this one, what I did were two PMSM machines are connected of one PMSM and one induction motor. If two PMSM motor are connected here, in that case, the switching and the controlling is done with the help of FOC method, that is field-oriented control. But if one of the induction motor is connected, then the induction motor controlling will be done with the help of VYF method here. Okay, that is the main thing. That is a major difference. Okay, so as here, this is like the controlling algorithm of grid side converter. I think this we have already discussed here less. So again, what we did, the three-phase voltage has been measured from the grid side end. It is being converted. Thereafter, stored value in the battery is being compared with the reference value. Thereafter, it is passing to voltage regulator. It is by the PI controller here, and it is producing your this direct axis current here. Thereafter, it is passing through its D-axis current controller and the Q-axis current controller. Thereafter, it is providing this direct axis voltage and the quarter axis voltage for the grid side. Thereafter, we have used the inverse Clark and path transformation for this reference value of three-phase signals. So normally, in this one, we have performed all the 4 quadrant operations. As we know that if both the speed and torque are positive, it is a forward motoring expressions. Okay. In the next one, it is if the speed is positive, torque is negative, the forward braking action is done. It is basically like the regenerative mode. In the third one, it is like both are negative, it become a reverse motoring mode. In the fourth one, if one is positive, another negative is called to be regenerative mode here. So we performed all this one here. Okay. So these are the few specifications of propulsion motor like this we have already seen. In the load emitter, we have considered induction motor operating 3 kilowatt, torque sensor 29 nanometer, IGBT controllers. We have seen like power tolerance converter, rectifier rating is 415 AC, chopper 600 volt AC, inverter 600 volt AC. More or less the same things here. The speed profiles we can measuring like this. So let's come to its output part here. So here you can see if we are tracking our speed in the first slide here, in the first one, so we are getting this pattern here. Okay, and for this the voltage level has been set up to like 74.95 this average value, and the real and reactive power has been set for 0.31 kilowatt and 1.6 kilowatt a year. Same thing if we are checking for this DC voltage level here, which has been set to a 620 watt. It is observing like this. Accordingly, we are getting this RMS value of current 17.83 and this other parameters like that. Similarly, in the third one, if you see the regenerative braking actions, as I told you that, the third one, we are getting a negative power. That negative power means it is showing that we are getting a regenerative braking actions. Accordingly, you can see in this one, we are getting a torque is negative. So this the third waveform is showing like we are getting this regenerative braking actions. In the fourth one, we are getting like the grid power. The power is 1.5 positive kilowatt. Reactive power is 0.55 kilowatt, means it is the charging aspect here. The other thing is like the battery power. Here you can see for the regenerative actions, our battery is charged with this minus so discharging with minus 0.85 kilowatt, 0.62 kVR and all. And in the torque profile, we are getting a negative. Or you can see the torque profile is moved from positive to negative. Negative means it is regenerative, positive means it is motoring here. Last one, the variation of this current profile with respect to time, vehicle emitter we have seen. Other is like the propulsion motor power. We are getting the real power, active power, everything here. Whether we are getting the speed profile, which is coming out probably optimized. Okay. So this is all about this hardware setup results. So we have seen like we have the performance of EV over on both software as well as hardware platforms. It is found that the hardware obvious more or less you can see we are getting the more or less good results in my hardware setup here. Again, the issue is the cost. You can see like we have taken the more power tolerance converter here. So obvious the cost is we have more cost. This is somehow around 275 to 80 lakhs setup here. Okay. So if I considering, but we can improve our profile of this charging and discharging. But more or less, I've used the method FOC control and this VY control here. But if you can use other algorithms, if you are developing another algorithm, the MATLAB Simulink platform, and an interface with the real-time system, more or less possibility that there could be possibility in the improvement of the battery charging time, SOC and all, even for the regenerative reactions. So this is the future of EV here. The sale can be increased. It is anticipated to have this 25 increment in the sales by 2030. More charging stations will be installed. More models should be available here. Okay. That at the end, I can say the future is the electric vehicle. Okay. So this is from my side. So any questions from the participant? So the podium is open to all.
Any questions, participants? The feedback link for session 2 has been sent to the group. Kindly all of you fill that. So all participants, keep your video on so that a group photograph can be taken. Bhavya,
Yes, ma'am.
take a photograph. Okay.
Yes, ma'am.
So no questions from the participant side. Okay, fine.
Done, ma'am.
Thank you, Abhinav sir. Done, Bhavya, done?
Yes, ma'am. Done.
Okay, thank you, Abhinav sir. And
Yeah.
thank you all the participants.
Thank you, ma'am.
See you again tomorrow. Okay, thank you, sir. Thank you.
Thank you.
So all the participants kindly fill the feedback form for session 1 and session 2 both. After 30 minutes, the feedback form you will not be able to fill those forms. And see you tomorrow at 6:30. Okay.
Thank you, everyone, for joining.
Thank you so much, ma'am. Good night, ma'am. Thank you so much.